Right, we're going to look at the two different types of waves, the main two different types of waves: longitudinal waves and transverse waves. In a wave, I basically said before that there's energy that's transferred, but the matter doesn't really move. Well, in a large sense, the matter doesn't move, but in a small sense, the matter vibrates. It gets displaced a little bit and then goes back from its displacement. Right now, so we're going to talk about the displacement of matter and the movement of the wave. So, if you have a slinky, we're going to start with the transverse wave because it's a little bit easier. If you have a rope and you've got your hand grabbing the rope here and you're giving it an up and down motion, the rope is going to go like this. You're going to get a wave like this. The rope is displacement up and down. So you've got an up and down displacement of the rope. Displacement. Oh, for Pete's sake, there's an up and down displacement. So the medium does move, but it moves and then goes back to its resting point, right? Its resting point would be a straight line. But the energy from the wave moves this way. The wave travels this way. So in this case, for a transverse wave, we say that the propagation of the wave is perpendicular to the displacement of the material. The propagation of the wave is perpendicular to the displacement of matter. That's a transverse wave. It's easy to understand. You can see that the matter is moving up and down, and the wave is traveling this way. That's why it's perpendicular, up and down and this way. That's a transversal wave. And you can think of a transversal wave as a vibration in a rope. So when you ask for an example, you can give a vibration in a rope. Right? This point here on the rope just moves up and down, and that's it. A wave on a water is not quite transversal. The wave on a water, this point doesn't move straight up and down. This point kind of moves in a circle. It goes up and then comes back and goes down. So a water wave is not quite a transversal wave. It's more of a circular wave. So when you think about a transversal wave, you have to think about this rope. This point moves up and down. So the displacement in the matter is perpendicular to the movement of the wave. A longitudinal wave, the propagation of the wave is in the direction of the displacement. The propagation of the wave is parallel or in the direction of the displacement. Now this is kind of hard to visualize. If you get a slinky, we have some slinkies that you should play around with a little bit, and you compress the slinky. So here's the slinky. You get an area of compressed spring here, compressed, and then you let it go, and then you'll get this area of and then you can get another area of compressed slinky here. Like this. So the slinky is being displaced this way. So this is our displacement. Right, if we put a dot on the slinky, this slinky will move forward, and then it'll move backward, and maybe back to there. So that spot will move back and forth. And this wave, the wave travels in this direction. So the displacement of a particle in our medium moves in the same direction as the wave travels. Sound waves work like this. Sound waves in air work like this. These can also be known as compression waves. Longitudinal waves, sometimes there's compression waves, where we have an area of compression or high density, and then there's this area of low density or rarefaction, and that is how a longitudinal wave looks. If you look on Wikipedia, you look up longitudinal wave, there's a very good animation for a longitudinal wave. And they call them compression waves or pressure waves. So longitudinal, the displacement of the medium is parallel to the direction of travel. In transversal wave, the displacement of the medium is perpendicular to the direction of travel. And those are your two types of waves.